Hello, everyone, and welcome to sunny Sydney. I'm going to talk about new Sunscreen test methods, and the title is With and Without Humans. You'll see the reason for that as we proceed. So, the topics I'm going to cover are the main changes in the very new version of the sunscreen standard from ISO, which is 24444. Then I'll cover new alternatives, which gets us into the non-human area. And then finally, progress with the test development and where it's all at. So let me give you a little bit of background on ISO. People need to appreciate that there's a very long process in the life cycle development of a sunscreen standard for ISO. So we talk to a minimum of about 5 years and a maximum which can be quite long, but the target always is to be challenged by a 5-year limit. So when we get to producing the final draft standard, it takes another 6 months from there or even more before the sunscreen standard is formally recognised as being official. And from there, of course, there's even a longer period, which will be the adoption by various countries. Can be many, many years, can be even never. So what do we do with the new version of ISO? Well, we replaced a further version that was produced and published back in 2010, and that was the first harmonised method for testing of sunscreens. In other words, it's universal. There were a few little changes to an addendum that was published after that, and the main changes are all to do with methodology. ISO standards for sunscreen testing are purely methods for testing. They don't regulate, only by implication in some countries, but essentially they're how to do it and not so much what to do with it. So I'm going to go through the changes that the major ones to the new standard. And what we call change one here is that we have done away with the subjective assessment that we had of our test subjects. So prior to this standard, you had the option of using an instrument to test skin colour, or doing a purely objective assessment based on the appearance of the test subjects and them answering some questions about how they experience the sun and some obvious traits in their hair, colour, etc. So this is now out. That's a very important change. It's something that you need to appreciate if you're having testing done. So what do we do instead? Well, we have an instrument called a spectrophotometer. It's a handheld device, and it's able to measure skin colour. Most of you would be familiar with how that works on a computer with RGB screens, etc. But in this case, we use a scale, which is called LAB, and it allows us to very conveniently measure the colour of the skin. And for the purposes of determining the skin types for testing, we eliminate the measurement of the red signal from the skin. And the reason for that is it makes it much easier without the red component to determine what's happened during the experiment. We also have situations where test subjects arrive late, sweaty, hot, very, very red in the face, and they will tend to change colour. So this instrument and this technique is now mandatory in the new standard, and it's an excellent objective way to measure the skin colour. So what have we done on top of that? As part of that change is we have taken into account different populations around countries. For instance, what we used to call the old skin type 1s, very light skins, almost impossible to recruit in a Mediterranean country like Spain. And at the opposite end in Asia, we have trouble with the type 3s. So we've given a provision to accommodate the differing populations. The second change is to very specifically define how the product is applied. In the previous standard and in the US model, for example, there's a fairly vague description of how you apply and evenly spread the test product onto the volunteer's back. So we've now said instead that there are a number of different methods that are used for different kinds of products. And one that I'll mention a bit later on in particular is how you deal with aerosols, which of course has been a question. And another area which has had some conflict of ideas about how you deal with it is powder products. So change 2 is to clearly define the methods so that they can be reproduced. To add to that detail, we've explained in the standard how to rub the product out by a set method, and we've determined an absolute limit rate of 35 seconds. I took a series of videos just for the purposes of ISO discussions, and in one lab case, it took them 4 minutes to actually get to weigh an accurate amount, to apply it, to rub it out, etc. So we really tied this methodology down as tightly as possible, all with the objective of reproducibility. Change 4 is to give much more detail in the standard about how the instrument is calibrated in relation to applying the light in an even way. This is particularly important for solar simulators which have a function of being able to expose through what we call multi-ports, so 5 or 6 simultaneously exposures. We can now say that we have a specification that makes sure the instrument is controlled in a way that that application is even. A little bit off the track now onto an associate method. That method is called 16217, and it's to do with water resistance. So it was the first publication of that method just around the time of the new ISO. And for products that need to be challenged with water resistant, we've also then added to that. So the 24444 reflects that and requires that step. So if you were running a test, you would now defer to the water resistance step. You've applied the product, you're now going to challenge it in water. And we now talk about controlling how that water resistance testing challenge is performed. So what we did there is we defined all the parameters that we could think of that needed controlling. Conductivity rather than water hardness, we discovered was more reliable. Compensated for different kinds of water around the world. Their potable water can vary quite a bit, particularly in the content of heavy metals or minerals, sodium, calcium, potassium, etc. And all of the other obvious areas like the pH of the water, the temperature of the room, the temperature of the water itself, the flow of the water, the speed, and how to sanitize after each test subject. So one of the very relevant issues with the water resistance is that there are now kind of 2 areas where the definition, do you remember I said earlier that ISO is only methods, but the definition of what the expectation of performance is varies quite dramatically in markets. So in Australia, New Zealand and the US, in a few other countries like Canada, you're not allowed to have any credit for wash-offs. So the SPF that you claim on your label is the post-immersion SPF. That's a very big difference to what happens in other markets. So in ASEAN, in the South American countries, Mercosur, in the EU, all those allow what I call a 50% discount wash-off. So in other words, if just a little bit over 50% of your product remains after the test of the water challenge, then you can still claim it's water resistant. Whereas in the other markets, as I said, the number is the number post-immersion. So you can imagine this now impacts on the test methodology according to the markets you're trying to target. So back to ISO 2444. Change 5 was the visualization of the MED, and previously we were trying to define that in words. So we decided to print in colour and to produce examples of how the back should appear when the exposures are read at the end of the experiment. So we have a definition of MED, which is a minimal erythemal dose that's created an actually visible red colour on the skin. And I hope you can see in this slide here that there's slight erythema at 0.1, which is half a grade of an MED, but the endpoint for this example is actually 2, where you can see there's much more discrete example of the endpoint. And beyond that, obviously, we're looking for the slight overdoses from increased challenge of the amount of UV light that we apply to each spot in the experiment. So how does this all fit together? Well, you have to reflect on the fact that in the end, we've just got a simple ratio. We've got a factor of the protected value in a specified term, and that's divided into the unprotected value. So previously we had all sorts of ways that people were measuring it. They were measuring millijoules, they were measuring seconds, they were measuring amps, they were really all over the shop. So now in this method, we very much defined that you have to measure joules per metre squared. So joules takes into account both time and the intensity of the dose applied to the skin. So this makes comparison between labs much more easy. This is an example of how it actually all fits together. So in this plot, we're showing the impact of that endpoint in joules per metre squared of the unprotected skin when it's exposed, and that's related to the ITA. So that's the value we're using as the rating for the colour of the skin. And according to this, there ought to be a trend line according to the skin type. So if you're going from lighter skin on the right-hand side to type, what was the old type 3, on the left-hand side, you can see there's a pretty good correlation between how long it takes to get a slight erythema, or the equivalent of a burn in the sun, according to your skin type. So we think we've now perfected most of this in the experiment in a way that's reproducible and is showing the impact of the reliability of the experiment related to different skin types. We weren't quite game enough to set limits for this in terms of a graphical limit, but in the next version of the standard, I think we flagged it, so I think you can expect there will be a way that you can have a plot, plus you can show the limit lines in that plot to show evidence of improved consistency even then with the test results that are used in the final report. Change 7 was a fairly dramatic one and took a lot of time to get to deal with. That was because we decided in our wisdom to increased the number of options for the reference sunscreen, which is used like an internal control in the experiment. And we now have 5 reference sunscreens instead of previously what was called P2, P3. So you can see from this chart, they're applied to a different expected SPF of the product that's being tested. So if you're running a very high SPF, say SPF 50 plus, then you use P8 as your reference sunscreen. And that way it's trying to, again, certify the reliability of the results. A big change, and which is one that I pushed vehemently for, was to have reports in a standardised format. And I think if you have any takeaway message from today, it should be that when you're looking now for a report from a lab and you've spent thousands of bucks on this, then you should be making sure that that lab is reporting in the standardised. Normative in a method means you must do it. So the report formats for ISO, new version 2019, are actually mandatory, and labs shouldn't be defaulting to something that they've used for years, which is their own in-house creation. So the other point about that is that it includes showing invalid test subject results. And here on what we call table 1 in the standard are the reasons why some results might be invalid. It's as simple as the test subject didn't turn up the next day for reading, or they came out of the time range. Something went wrong with the reference standard, various other inconsistencies. But instead of burying them and doing another test subject, then labs are required to explain, to notify and to explain why they've been omitted from the final values that are put into the minimum of 10 test subjects that are needed. So there are real changes to that standard. And then in the case of amendments, some people say, why were the amendments added? These are very minor editorial changes which really don't have a great impact on running the test standard. I know in Australia that TGA here will accept the previous method without the amendment if you happen to have retested your product in the intervening period of the couple of years between this publication of ISO and the publication of the amendment. So, in fact, they're just related to more specifications about the quality of the beam from the UV instrument. There's the solar simulator we use, and a bit playing around with stats. And then we looked at stability, shelf life of P8 and changed the viscosity limits. So these are really not of consequence in terms of 2019 published method. So I need to just come into talking now about what are we doing without the use of humans. And there are quite a few methods around. The method ISO 24443 has been around for as long as 24444 and used in many countries around the world prior to that. So that's the method of modelling on PMMA, which is plastic, and using a method with a spectrophotometer that's specifically designed to measure the amount of light that's transmitted. So they're called integrating sphere spectrophotometers. That's what we use. And I just now can show you how one of the new in vitro methods that's under development, which is ISO 23675, compares with the old method 24443 in relation to now estimating SPF rather than UV UVAPF in vitro. So that new method, we'll call it in vitro method number 1, is based on a method that's pretty tried and true for probably about 20 years now. So that's a new development, and it's on its way. We'll talk about that in a little while. So here is how that method works. It requires mandatory robot to spread evenly the product in a reproducible manner. And then again, the instrument that's been used, LabSphere 2000 is a good example, is the same instrument as labs would have for doing their in vitro UVAPF. So it's quite elegant and an extension of the same sort of technology. So that's in development. And the second one that's in development is what we call hybrid in vitro. So you can see on the left, it still involves measuring on the skin, but you can actually measure it on the skin, on other parts of the body if you need to, on the face, for example. You can measure it directly by using an instrument that measures how much light is actually being absorbed by the sunscreen. So it's a reflectance spectroscopy instrument. There's a few of them now available. Solar Light has one under development. Bentham's had one that you can see has probably been around for about 40 years. It's not a new kind of technology, but it's now written into a new ISO standard 23698. So here's an outline on the left of how that works. You're purely applying the film to the skin as before, as in the in vivo method, and then you're measuring and computing the data and using either a monochromator or a multichromator, polychromator diffuse reflection device. And you can see in the original experiments that were produced for ISO, there's a very good correlation. So it's still using a human skin, but the dose is only, even with the product applied, 1/2 of the MED that would be used in a normal ISO 2445 method. So if this one gets up, it's really non-invasive. It's almost an entirely in vitro method. You can apply a lot of products on the back of the test subjects in one day and run multiple studies. So that means the time frame for exposures is down to seconds instead of minutes or hours, and the test subject can be reused within a few weeks. So excellent potential for this new method. And I need to now just reflect on in silico. In silico has been around, I think, maybe for about 10 years. It's offered free online from two of the suppliers, BASF and DSM, who are the major suppliers of the raw materials we use, the UV actives for sunscreens. And my experience with this is they're quite conservative. So if you get a product that you want to challenge without doing any testing, then it's still a good value to run this on your computer, costs you nothing, and you can model it. And my experience is you might get maybe 30% understatement, but I've not seen instances where in silico is shown massively different in vivo real results, not in vivo results that are too optimistic, shall we say, from some laboratories. So where are we at? What happened with ISO is we put the clock on stop for the two in vitro methods that I've mentioned. And in the interim, Cosmetics Europe have recognised them both for use for R&D purposes. So at this stage, they're not a substitute for the full in vivo, what we call the gold standard 2444. They're actually on their way to having alternative standard option, but they're not there yet. So what's happening in the interim, and why the button stopped on the clock, is that we're waiting on results of a very expensive survey. Became too expensive for ISO to actually manage and much too complex. So what we did was we went on a fundraising drive and handed over to Cosmetics Europe, and you can actually look up the progress on this project at the connection, the link that's on the bottom left of the screen now, but it's just all SPF, it's a website. There was 700,000 euros raised the last time I checked towards this study. It started right in the middle of COVID, and a lot of labs, of course, had to close because of COVID. And now it's been administered by Cosmetics Europe. At this point in time, the products have gone through screening by the gold standard of 32 sunscreens involved. And then they will be tested by what I mentioned as the robot method and the hybrid direct reflection spectroscopy method. And that data will be provided back to the ISO committee, the experts, to be crunched and discussed, and how we proceed there in terms of cross-validating the two new methods. So we're still not quite at the end of the process. We're in a fairly complex stage of testing. So my suggestion is to you, clearly do not ignore for now the value of testing to the new ISO 24444. The reason is that last time I checked, there are more than 60 countries who still recognise it. It will take many, many moons, if ever, for all countries to possibly abandon the in vivo method. Obviously, we are animals, and there's a non-animal testing argument towards this. But primarily, for now, if you have your product tested to 24444, then it means it's going to be recognised testing appropriate to most parts of the world. Just a couple of exceptions, USA being the big standout, and China now has recently come on board, fairly close methodology. So in summary, we got these different methods at different stages of evaluation, and in the end, we will probably come up with options rather than dictating a final method. I'm sure most of the standards are in existence now for sunscreens will be around still for quite a while into the future. So we're far from the end. We're well on our way towards very state-of-the-art types of options for testing, and there's more to come. Thank you for your attention.